We're going to be exploring the equation of a circle now, and this is going to be relating to our trig later on when we start looking at the unit circle, but we're going to look at the general equation of any circle. The general equation of any circle is x squared plus y squared equals r squared, where xy is a point on the circle and r is the radius of the circle. So this right here tells us the equation to any circle. As long as we have a point x, y, and a radius, we can do the equation to any circle. So let's take a look at some of the examples. What is the equation of a circle that has a radius of 2? Now these, you'll be happy to know, are not difficult questions at all. We start with that general form of the equation, x squared plus y squared equals r squared, and the only information we know is that the radius of the circle right here is 2. So that's 2, but it's squared, x squared plus y squared. So the equation to this circle is simply x squared plus y squared equals 4. That's it. So any point x or y that would make this equation true would be on that circle. So let's take a look at the next example. Is the point 6, 4 on a circle that's centered at the origin with a radius of 12? To do this, all we have to do is see if it actually satisfies the equation at all. So here's the general equation of a circle, x squared plus y squared equals r squared, where r is the radius. And it's saying, you know, okay, so if the radius is 12, this is 12, so 12 squared. And now it does tell me a point xy. So let's put it into the equation. So let's say 6 squared plus 4 squared. Does that equal whatever 12 squared is? So if we look, we have 36 plus 16. We want to know if that equals 144. So it should be pretty obvious right now that 36 plus 16 is definitely not 144. And since that all these values in this question do not actually make the left side of the equation equal the right side of the equation, we can say the point 64 is not on this circle. It's just that easy. If the left side did equal the right side, then the point is on the circle. So let's take a look at an example that would follow that. And here it is. Example. Is point negative root 7, 3 on a circle at the origin with a radius equal to 4 units? So is that point on this circle? Same work's going to take place. We're going to say x squared plus y squared equals r squared. My radius, they say, is 4, so we're going to put that in. Now we got this point xy again. It's going to be very important now that we remember that when we substitute in, we need brackets here. So that's squared, negative root 7 squared plus 3 squared. We want to see if that equals 4 squared. 4 squared's easy. That's 16. 3 squared, that's 9. And hopefully from grade 10 and grade 11, you can remember that negative times a negative is positive, and the root of 7 times the root of 7 is simply 7. And if you look at here, 7 plus 9 is 16. 16 does equal 16, so we can conclude, yes, it's on the circle, just simply because the left side equaled the right side. So now we're going to extend this concept of a unit of a circle to something new to grade 12, and it's going to be very useful to you in this whole unit of trigonometry is the unit circle. Now the unit circle is simply a circle and it's centered at the origin, which most of the stuff is we've taken in, or we do take in this unit, except now we just say, you know what, the radius of this circle is 1. So all that means is now we have the origin being the center of the circle. It comes out here to 1, goes up there to 1, comes back here to 1, goes down here to 1, and of course this probably is not going to make too much of a nice circle, but this would be the unit circle. Okay, that's it. The radius is 1 unit out each time. The equation then to the unit circle is fairly easy. We just say x squared plus y squared equals the radius squared, but the radius in a unit circle is always 1, but 1 squared, if we put that in there, is simply just 1. So the equation to the unit circle is always this. Now we can extend the concepts that we just talked about on those other examples to a unit circle example. So here's the next example. We have a point x and 5/13 that is lying on the unit circle. So we know for sure that it is on the circumference of the circle. Now it's saying, what's the value of x? Well, we start with the equation of the unit circle. X squared plus y squared has to equal 1. And it's 1 because the radius of a unit circle is 1. We're trying to find x, so we don't have a value to put in there. It just stays as x. Now we have to add whatever y was, and that's the 5/13. And we're going to square it and 1, because this is x and this is y. So with this right now, we just have to do our simple math. X squared plus, if I square this, that's 25 over 169 equals 1. We take away the 25 169th from both sides. So I'll show this step. Take it away from here, 169, and take it away from here. And you can use your graphing calculator to figure out that 1 minus 25 over 169 is 144 over 169. Now what we have here is that x equals 144 over 169, or sorry, x squared does. So we have to take the square root of 144 over 169. But remember now in math, when we take a square root, there's a principal square root, the positive one, and there's a negative one. So now the value of x that would make this unit circle true would be a positive 12 over 13 or a negative 12 over 13, because the square root of 144 over 169 is 12/13. So x could either be on the positive x-axis or it can be on the negative x-axis, and both of these x values would let that original point of x and 5/13 lie on the unit circle.